Takes to a talk on practical patterns. I've been a little busy. Dev Academy is a economic boot camp, and it turns out the students work long hours and want tutoring. Who knew? So I'm working for a crust for a change. This talk kind of grew out of Dev Academy as well. I spent 3 weeks in San Francisco at the original boot camp, Dev Boot Camp, learning how they deliver that much content in that short space of time. Dev Boot Camp is a Ruby school, so there's 75 students there at any one time, all learning Rails. And students kept coming up to me and saying, "Is it true that you're a .NET developer?" Yeah. "Is it true that you need 5 brains to program in C#?" No. Well, it's just a programming language, you know. And I kept getting asked this, so I volunteered to do a talk. They have an evening a week when they get speakers in just to present on random things. So I volunteered to do a talk on why C# and Ruby are pretty much the same. So I wrote some Ruby code and some C# code, and my talk was going to be, well, here they are being the same. Any questions? And then I figured out that was going to be a pretty short talk. So I started exploring the reasons why they're the same, and it turned into like a history of programming language and a history of IT and pretty much a history of men with beards. So I have notes, and I'm going to try and not read them. I've got lots of notes. I'm going to try to not read them, but I'll try to keep broadly the structure. I gave this talk 3 weeks ago, and I did a little practice today, but I might be a bit all over the place, so I ask for your forbearance. Okay, cool. So, this is me hard at work in San Francisco, sailing on the hallowed ground where the Americans kept the stolen from us. Cool. Okay, so none of you are .NET developers. You're not JavaScript developers, you're not SQL developers, you're developers who have a first language, a primary language. That's not a great display, is it? It's a bit compressed. It's alright, it's just going to make lots of fat geeks look slim later on. Cool. We can all program. Hands up for your programs in C#. Cool. Keep your hand up if you've got a bit of JavaScript, got a bit of VB, got a bit of T-SQL. These are all like languages which are a lot more different to each other than something like C# is different to Ruby. Excellent. Okay, so the analogy is often drawn that learning new computer languages is like learning new human languages, foreign languages, like learning French or whatever. And I don't think that's really true. If you look at the vocabulary of English, it's 62,000 words, something like that. Anyone know off the top of their head? Any English majors?
It depends which dialect you talk to.
Yeah.
Talking 40,000 words and so on.
Yeah, it's like quite a lot of words, but the vocabulary of C# is a couple of hundred. So a better analogy would be that learning a new computer language is like learning something like Simple English. Does anyone know what Simple English is? Oh, interesting. I expected at least one. Simple English is a stripped down version of English with a 1,000-word vocabulary. It's got the most commonly used 1,000 words, and it's designed for people who don't have English as a first language to enable them to get functionally communicating in English quickly. Have a look at XKCD, number 1133, for an excellent and amusing explanation of what it is, or just Wikipedia it. Like, it's a really interesting topic. So I reckon learning a new computer language once you've got a computer language is a bit more like learning simple Estonian when you already know how to speak English or French or German. Like, you know that there's a grammar, you know there's a vocabulary, you've got these basic concepts down, you just need to learn a bunch of words and some new ways of stringing them together. 3 quick demos. I'll do this. I wrote the same code in as many different languages as I could find. So let's look at some C#. It's probably our our lingua franca. This program is a tip calculator. One thing I noticed while I was in San Fran was they never put the actual price of things in menus, they put the price before tax and tip. So you don't have this like colossal moral dilemma or like social angst attack of how much should I tip, is I tip before tax or after the tax. So here's a tip calculator program, so it takes an amount and a tip percentage and does some maths that I can't quite remember, modulus there, so I think it rounds it up to the nearest 5 or something, returns a tip result. So C# code, same thing, written in Ruby. This is Iron Ruby, so compiled Ruby that runs under the .NET framework, which is kind of defeats the point of a dynamic language. But anyway, this is Iron Ruby, and for anyone who doesn't speak any Ruby, this is still pretty understandable. We've got a tip calculator, def, well that seems to be some sort of method. Take some parameters, yeah, these look like mathsy things. There's a ternary in there. It's returning a new tip result. Okay, everything's back to front, but we can see what's going on. Even if we don't have any Ruby, like we can pretty quickly read and understand that. Like they're quite similar languages. Similarly, Python. You want to open? Hey, there we go. Alright, well it's a bit more densely packed and it doesn't appear to have any ends to any of the methods or classes, but yeah, there's classes, there's a thing that's a method, similar sort of maths operators, oh yeah, there's an if. So again, like pretty familiar things. You know, we can read and write C# or other languages. We can get to grips with what's going on with these. But why are they all so similar? You know, like there's 3 different languages, but they're all really alike. They're all similar because they model similar concepts. They're all modelling classes. You know, they're just different expressions of the abstract concept of a class, or different expressions of the concept of adding things together. And they all have a common ancestry. And to understand a little bit more about why they're so similar, we need to understand a little bit more about that common ancestry. So I present to you finest visual in the history of visuals. I'm wasted as a developer, I should be in design. A brief history of code. So I'm going to go through a history of hardware from kind of the first thing that looked like a computer and wasn't a slide rule, up to the point where things that are recognisable as computers start to emerge. And then I'm going to dive into the history of some of the languages that arose around that time, and some of the bizarre individuals who were responsible for this. I'm going to ask for lots of audience participation. What is this?
Babbage.
Babbage and his difference engine. Charles Babbage in 1840-ish, I've been 1842. Do feel free to correct me on dates, names, like anything factual. I will get it all wrong. Babbage, 1840-ish. Babbage went to Cambridge University. He didn't really like the way academia worked. He founded a society while he was there, or joined a society, which did logical and mathematical things, and came up with this, the difference engine. It's made of cogs and brass and stuff. It's entirely mechanical, and it does maths. It's possibly where the word bug comes from, or possibly not. But a bug, in the context of something like a difference engine, is an actual bug. It's an insect that's got itself jammed between a couple of cogs and is stopping things moving around properly. Babbage also invented the cow catcher, which is the thing that goes in the front of railway engines and sweeps livestock off the line. I don't know why he invented the cow catcher. And found the time to have 8 children, which, even by the standards of quite a fecund age, is a lot of children. He never built the difference engine. He could never get funding. He annoyed everyone he met, pretty much, particularly politicians. Didn't like politicians. When asked in the House of Lords, if you put into the machine wrong figures, will the right answers come out? He responded, I'm not able to rightly apprehend the confusion of ideas that could lead to such a question. So yeah, Different Central was finally built in 1993, possibly, and one came to New Zealand and was up at the Reserve Bank, I think. Or was it the Mint? About 4 years ago?
Reserve Bank, I think.
Yeah. I didn't go and see it because I was doing something that seemed really important at the time, and now I really wish I had, of course. Okay. Who's this?
Ada.
Ada Lovelace. Augusta Ada Byron, Countess of Lovelace, normally called Ada Lovelace. And I think a really great thing is that one of the founding fathers of computing was in fact not a founding father at all, but was Ada Lovelace. She worked with Babbage on the Difference Engine. She was Lord Byron's daughter, Byron the romantic poet, who was probably best known for wandering around Italy in a big shirt trying to get laid. Her mother decided that Byron was a bad sort and there would be no poetry for Ada. She would study mathematics in an attempt to stop her wandering around Italy in a big shirt trying to get laid. And this worked. She took to it, and at 17 she met Babbage at a party, discovered he was working on a machine to do mathematics, and said, yeah, I'll get involved with this. She has a language named after her. A very unsuccessful attempt to teach me this language was made when I was at university in 1994. It's a very strongly typed language, popular in defence. I have no idea why. She died aged 37. Who knows what she would have gone on to achieve. Then what happens also during the 1800s? Nothing actually really happened in IT in the 1800s, surprisingly. Alexander Graham Bell didn't invent the telephone in 1875. A German fellow called Carl Friedrich Gauss did in 1833, or if you're Italian, Innocenzo Manzanetti in 1844. Gauss, you know the name, a Gaussian blur, that's Gauss. And who remembers degaussing on CRT monitors? Yeah, that's right. Oldies in the house.
Who made the mistake of having their floppy disks too close to the monitors?
No, we never did. I think
They end up very blank.
later monitors were shielded against that sort of thing. Maybe I had a particularly advanced one. And someone with the fantastic name of Seaman Korsakov, who previously had careers in the military and homeopathic medicine, somewhat unexpectedly invented the punch card in 1832, of which 1832, sorry, of which more later. What's this? An Enigma, fantastic. Invented in 1920-ish by the Germans. It's a cryptographic machine. It works by setting these rotors here according to a pattern which is in a code book, and it then scrambles things. You press a key and a letter lights up. So, Q becomes W and Z becomes 3 and all this sort of thing. Anyone with an identical Enigma machine and the same code book can then set the machine up in reverse and decode. So it was invented in the 20s, was repeatedly cracked by Polish for years and years and years. So there was this cycle of improve the Enigma machine, the Poles would crack it, improve the Enigma machine, the Poles would crack it, and that went on until about the Second World War, by which time the Germans had pretty much got it impregnable. It was broken during the Second World War after some heroic Poms captured a U-boat which had an Enigma machine and code book on it. Said Poms mysteriously turned into Americans when a film was made about it in 2000 and something, U5, whatever it was, 571? Yeah. And this man, who is this? Turing, well done. Fantastic. Father of computer science. The day after the Second World War broke out, he went up to Bletchley Park, which is halfway between Oxford and Cambridge in England, pretty much knocked on the door and said, hey, I'm pretty good at maths, how can I help? So they put him to work on code breaking with a team of mathematicians who are mainly women. Most of the blokes are over on the continent fighting. And an electromechanical machine called the Bomb. I haven't been able to find a photo of the Bomb. He was an eccentric man. He would chain his mug to radiators to stop people nicking it. And if he had to go to London for meetings, he would run. He was an accomplished long-distance runner. He was about 40 miles down to London. He'd run it. He was gay. And after the war, after he'd finished being useful, the British government said, right, you can either go to prison or we can chemically castrate you. And he chose the chemical castration, and in 1954 he killed himself, and that was the end of Alan Turing. Not the finest hour of the British government. This is an ENIAC, a US mainframe computer used for computing the trajectories of shells. It was built in the late 40s, about 46, I think, and ran for 10 years or so. It was programmed by plugging wires into it, much as you would with a telephone exchange. Well, that's a good transition. This is Impress.js, by the way. It's HTML5, CSS3, JavaScript, Matrix, with an editor called strut.io, before you get too impressed with my HTML skills. Okay, that's a valve, and a transistor, and a silicon chip. So these all do the same job. You know, they can represent a 1 or a 0, pretty much. Yes, the ENIAC, programmed by plugging wires into it. At some point in the 50s, people realised that this was a bit shit. So they invented a better system, keyboard. Unfortunately, that black and white thing is the keyboard they invented. That is a Hollerith punch card machine. I have one of these.
Cool.
It's back in the UK in my parents' loft. I found it lying around in the attic at a firm I used to work at. And I came down, I was about 25, I came down bearing it in great triumph. Look, I found something. And I'll tell you a bit more about that later. The other thing is punch card. So it's got 80 columns on it by 8 rows. So you can knock holes in it, and each hole represents a bit. So the 8 rows together represent the byte. And it's 80 columns wide, and that's why you have 80 character wide screens, which, again, the older generation will remember better than the younger.
One line of code.
That's, yeah. So the line, can you really see it? Yeah, it's up there. It's got an English representation of what this means, exec prop something or other. Obviously, this is still a bit of shit. You know, top user experience experts of the day would have gone, hang on a moment. So punch cards, you feed these back into machines using this thing, a punch card reader. So you stick a deck of punch cards in, and it goes nuts like a money counting machine. This is more crap technology from the 50s. Does anyone know what this is?
Those solenoids.
Bubble memory? No.
This is a torsion wire delay line. This is memory. You have electromagnets which put a twist into that wire. So you turn them on, turn them off. So you put a little twist, and the twist goes off down the wire like a wave. And by putting lots of twists into the wire, you can queue up lots, like a twist represents a 1, and not a twist represents a 0. So you can queue up lots of 1s and 0s on that wire, and they go round and round the wire, and then we get to the other end, and a little listening thing goes, oh yeah, twist, and re-queues the twist. So by having a longer wire, you can put more twists in it and have bigger memory. That's about a kilobyte. This is real. This is a real thing. This is core memory. So these are toroidal magnets, electromagnets, which you can magnetise in either direction. So magnetise to the left is 1, magnetise to the right is a 0. Further bizarre and crap stuff in the 50s. Core memory. Teletype terminal, fantastic. This is a huge leap forward. This is a punch card punching in thing and card reader built into one machine. And this is a DEC VT05, which is an electric VDU keyboard teletype thing. It doesn't have punch cards anymore. This is like the first recognisable computer, I think. Yeah, it's just a terminal. It's not doing anything smart. It's just talking to a mainframe. This is 1970, I think this is invented. I do have that in my notes. Yeah, 1970. DEC VT05, get in. Still interacts with the mainframe. So it's a dumb terminal. Doesn't have any processing power. I'm not going to go into the invention of the microcomputer, the Apple II, the BBC Master, the IBM XT. those came along and kind of changed the face of computing forever. In fact, someone should do a talk on all of the things that have changed the face of computing forever. Just like pick 10 inventions that have changed the face of computing and do a talk about it. It would be fascinating. I'd love to see it. If anyone wants to do it, talk about it, I'll help research it. Researching this talk was great. It was like the most fun. Okay, so the point of all of this is sometime in the middle of the last century, things that looked like computers started to emerge. And around the same time, things that looked like languages started to emerge to program these computers. Before we move on, though, does anyone know who this is? I'll be very surprised.
I've seen that photograph and I can't think of the name.
Really? Far out. That's my mate Mick Eakers.
Alright, I don't think it's somebody else then.
When I came down from the loft bearing in triumph the Hollerith punch card machine, Mick said, "Oh, there's a program on that." I said, "You what?" It's a bomb sight out of a Lancaster or something. How did you learn to program on it? And he got some punch cards and he showed me. He learned to program on a Hollerith in Fortran. And he told me some stories about losing weeks' worth of work by dropping a box of punch cards. He learned from that. You sort of draw patterns on the top with a magic marker, and then you can always put them back in order. You could fix defects by sticking bits of sellotape over holes and knocking out holes with a hole punch. And you got your bug reports back in the form of a large box of paper, like a core dump. So next time jQuery doesn't do what you want, stop moaning. There's an awful lot of words on that page. Rah, 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 rah. What's this? Okay. This is all of the programming languages ever. In a big sort of genealogy, family tree. It's a little bit complicated, so I made a slightly simpler one. It's still a little bit complicated, but at least we can start to understand it. So over here on the right-hand side are modern languages, things that we work with today. VB.NET, if you work with VB.NET, I'm sorry. C#, F#, JavaScript, and here's Ruby. Obviously I prepared this talk for Ruby schools, I have to put Ruby on there. Notice it's not quite as evolved as C#. And then over on the left, the common ancestors of all of them, and then the family trees of languages coming down from those original ones. There's a lot of begatting in the history of languages. Fortran begat BASIC, begat Quick Basic, begat Visual Basic. It's a bit like Genesis chapter 11.
Where's PLN?
That's a very good question. Where is PLN? What is PLN?
The language that was used in what symphony?
I don't know. It's actually I do. It's there. So this isn't a complete thing. I've chosen pretty much the common things. So back in the 50s there were a big four. There was Fortran, Four-Minute Translation, which was a sort of scientific and mathematical language. Out of that came Algol, algorithmic language. What else was around then? COBOL, that came up around there as well. Common objectified
Common business
oriented language. What else was in the 50s? Simula would have been around there. I haven't got Simula on there. Simula, I think. Oh yeah, no, Simula's Simula. Those are the early languages. Let's dive Fortran. I've got some notes on Fortran. 1953, Fortran emerged. It was developed by IBM, and it had a three-way if. I don't even know how that would work. I don't think I'll...
Else.
That's a two-way if. If
That's
this...
three.
Oh yeah, true, okay.
The ternary operator in PHP.
If this, else that. If this, else that, that's into two. Two outcomes.
On WWTF it's true, false, and found. So three-way boolean.
That's probably it. True, false, don't know. Apparently it's good for scientific stuff, numerical analysis, the kind of things that early computers are used for. Like if you couldn't be bothered to do it, the slide rule, use Fortran.
Where are the SQL-like languages?
Haskell-like languages, they are on the other diagram. This is not complete. This was mainly some focused around C# and Ruby and why they're the same. So, okay, creators of languages.
Three-way if parser controlled one of three locations depending on whether the result of the arithmetic statement was negative, 0, or positive.
Ah.
It wasn't Boolean based, it was sign based.
That's maths.
Different options
Wikipedia
as
for the
well.
win.
Sociologist. No speaking mathsy.
Honestly.
Okay, here's this. Grace Hopper. Another great female role model in IT. She was a rear admiral. Well, she finished her career in the US Navy as a rear admiral. She wasn't a rear admiral all the way along. She retired about 4 times. You know, she decided she'd had enough and retire, and then the Navy would go, oh, computer, oh, it's too hard, come back. And so she retired and then retired and retired and then retired. She wrote a compiler in 1952. Prior to that, people were translating code into machine code, presumably with a pen. And she also possibly invented the term bug for the same reasons that I said the difference engine may be the origin of the term bug. She did a lot of work on COBOL as well.
First bug was found in the ENIAC, wasn't it?
Yeah, she would work in the NX. She was in the Navy, and the NX was a Navy computer.
Not that got caught between the contractors.
Yeah, she was the one who took it out and put it in the logbook with the note of the bug. She used to hand out nanoseconds.
Hand out nanoseconds.
Yeah,
How does that work?
in terms of putting the context on it, she'd hand out a bit of wire just over a foot long.
Yes.
That's the distance that light can travel in a nanosecond.
Yeah. And after she retired, she used to go around schools, like lecturing on why it's great to get in computing, wearing her Rear Admiral's uniform. She sounds superb. I would love to have met her. What's it? Oh, this is ALGOL. Like it's recognisably code. There's some sort of leap going on there. I can see the word for, step 1, yeah. That's a for I equals kind of style of leap. I love the fact that comment is preceded by the word comment. ALGOL. Oh, that's ALGOL as well. And while I was researching ALGOL, I came across this. ALGOL is this character in a computer game. He has 10 weapons, including a cannon that forms around his hand and a sword with the power of pure chaos. I reckon that Grace Hopper could take a good fight. This is, look at these beauties. This is the golden age of facial hair. Who are these fine gentlemen?
Dennis Ritchie and Ken Thompson.
Dennis Ritchie and Ken Thompson. I'm impressed.
Linux heroes.
Yeah. Dennis Ritchie invented C from 1969 through 1973 at Bell Labs, which is an AT&T facility. So we talked about Bell inventing or not inventing the phone earlier. He didn't invent the phone, but he popularised the phone and founded AT&T, which was the biggest company in the entire universe until broken up by antitrust people in the 80s. And they did a lot of research at Bell Labs, named after Alexander Graham Bell, in computing through the latter part of the 20th century. And Dennis Ritchie invented C there over 4 years. He did a lot of work with the other guy, Ken Thompson, on Unix. Who
Ken
died?
Thompson wrote Unix, and Dennis Ritchie died last year.
Yes, in the same week as Steve Jobs, who I believe did some marketing.
There.
So yeah, if you've heard of Steve Jobs and not Dennis Ritchie, then shame on you. We'll do CPL. CPL came before C. Actually, I've skipped one. CPL came out of ALGOL, and I couldn't find out too much about it. I think it might be made up. It was ALGOL didn't natively have any I/O, so I don't really know how you got ALGOL into the machine or ALGOL to output anything from the machine. So CPL was kind of ALGOL wasn't bolted on I/O, but it was invented in 1960. The compiler didn't appear until 1970, by which time C was around and people didn't need CPL anymore. I can't really find any documentation on it. I'm not sure it's real. Dennis Ritchie. Have I said anything about Dennis Ritchie? Yes. 10 years later, Bjarne Schustrup invented C++. It was originally called C with classes, which is a very good description. It is C with classes. It's called C++. I'm sure we all know it's called C++. Big joke, laugh it up. He has a slightly smaller beard than Dennis Ritchie, but still magnificent. Larry Wall, 1987, inventor of Perl, the Swiss Army chainsaw of programming languages, the duct tape that holds the internet together. He has a magnificent moustache. anything else interesting about Larry Ward? Oh, it has. It's got an interpreter written in C. Yeah, there we go. Everything's written in C. It has powerful text processing features. I don't really know what they are. 2 years later, 1989, Python was invented by Guido van Rossum, a Dutchman. I couldn't find anything interesting about Guido van Rossum or a picture of him with a beard, so I haven't included a slide. Who's this?
Richard Stallman.
Richard Stallman, the maddest man in computing.
He came to New Zealand a couple of years ago.
Did he?
I met him.
Oh, yeah, he
Really?
blessed us. And he gave us the official GNU blessing from the Church of Emacs.
He's absolutely insane. The other guy is, what's his bloody name? Mats. Yukihiro Matsumoto, invented Ruby in 1993. But the real character here is Stallman. He's the founder of the free software movement. It's different to open source, and he'll tell you why. I urge you to Google for him. I'll have a look at his personal website. There's an email that he famously sends out if you want him to come and speak at your conference with an amazing list of conditions, including his preferred sleeping temperature, why you shouldn't pay for transport for him with anything other than cash, how much he likes parrots, why you shouldn't buy him a parrot, food he likes, why you shouldn't be offended if he uses his laptop at the table, preferred internet service providers.
He doesn't like cell phones at all, anywhere around him, or travelling with them.
Oh, okay, that's
Because they're all closed source, you don't know what's on the cell phone.
very, very odd. And he's got a page of puns, which are horrendous. Google it, Richard Stallman, amazing, absolutely amazing. And the other guy's Matt, who invented Ruby, which he named after one of his colleagues. He's married, he's a religious man, he's got 4 kids, but he named his programming language after one of his colleagues. Interesting.
A colleague called Ruby.
He did? No, it was Ruby was the birthstone of one of his colleagues. He thought Perl was a toy language and that Python's OO felt bolted on. I don't really know any Perl or any Python, so I can't comment on whether it's accurate or not. 1995, Brendan Ike. Again, there's no photos of Brendan Ike with a beard, so I haven't included a slide. He invented JavaScript in 10 days to stick into Netscape Navigator version 3, maybe. He's been on hot water lately. He gave a donation to some cause that doesn't like gay marriage, so now he's not the chairman of Mozilla anymore. Shame. So that's to be Brendan Ike. This dude, though, Crockford, the author of JavaScript The Good Bits. If you haven't read JavaScript The Good Bits, read JavaScript The Good Bits. He's done more for JavaScript than Brendan Ike ever did.
You should watch this guy's presentation from WDC a couple of years ago about programming conventions and working with your brain and not against it and stuff. It's great. Great
Yeah,
presentation.
he's awesome. And JavaScript The Good Bits is a great book.
Can you put a link to that up somewhere?
Yeah, I'll find it and stick a link up.
Cool. He now works for PayPal, but he once founded a company with 2 people called Randy Farmer and Chip Morningstar. If I don't know what this company did, but if I ever meet people called Randy Farmer and Chip Morningstar, I'm forming a company with them.
Netscape Navigator 2.
Let's get Navigator 2. This is great. I'm my own researcher, on hand. And you can follow at Crockford Facts on Twitter. And Crockford Facts on Twitter informs me that Crockford's beard has solved pi to the last digit. Kitty. Anyone?
Is that Anders?
It's Anders Hellberg.
Anders Hellberg. C# in 1999 for release 1 of the .NET framework. It was originally called something really mundane, C#, like C++ and a bit better or something. But then it became C#.
And before that, he did.
I don't know.
Before that, he worked for Borland, who was behind
Turbo
Object
Pascal,
and
Object
Delphi.
Pascal.
And a lot of the syntax Delphi came out of what could we have if we could have anything.
Yeah,
And before that, he wrote the original Turbo Pascal.
cool. And now he's working on TypeScript. So he keeps busy. Sadly, I couldn't find a photo of him with a beard, but he might be having a haircut in this photo.
C# reminds me more of Java than Pascal.
That's kind of where C# came from. It was a Java killer, which is why on that diagram, which you come back to, which you can't really see in the bottom corner, there's some dotted lines from Java to C#. It's got a lot of Java kind of features: generational garbage collection, generics, curly brackets, that sort of thing. And back to the big filled-in genealogy. There you go. So you can see I've put the C# sort of a bit Java-y, and there's some other stuff on there. So we haven't covered everything, but we've been through that C# lineage, which is the bit that we're really keen on. I guess the takeaway for the audience I wrote this for was you just trained to be Ruby programmers, but you haven't really trained to be Ruby programmers. You've trained to be programmers who think in classes, who think in variables, and you can take those skills and apply them to any language. And this is why they're all so similar. Having said that every language is the same, though, I did feel the need to throw in this nuggety little gem. Who's had the good fortune to work with XSL? It was all the go in about 2002. We thought this was the future. XSL, for those who haven't used it, is an XML, a declarative, it's not imperative, it's declarative, XML processing language written in XML. What? When I say it's declarative, you don't say start, run, do this. You say, here are some templates. Apply them. For some reason it applies the one at the bottom of the file first, then works out. It's considered bad form to have one template call another. You're supposed to just let the XSL processor find its way. And look at it. Like, what the hell's going on? This is awful. There are some things like I love the fact that everything has to start with XSL colon. I think that's fantastic. Like, just wasting space. The multiplier is a multiplier.
You could declare it as the default namespace and get away without it.
I suppose you could. But divisor is the word div. There's something else that's funny as well. Mod isn't a percentage because a percentage is a thing in in XHTML, I think. So we have to have mod there. Look at all this crap. Like, to create a variable, it's like 17 lines of code. It's evil. I don't know why we thought this was a good idea. I don't know. So it doesn't appear on Wikipedia's page of every programming language ever either. I think it's like an embarrassing bastard child. we wish we'd never known.
You can change that.
I was just going to have it in. I think you've forgotten something.
On the discussion page.
Is that?
Probably have a look.
I'll
16 pages of argument about whether XSL is a real language,
or whether it's. I think it's just too confusing. It's modern as well. It's Turing complete.
It's Turing complete.
I forgot to say Turing complete. Turing gives us Turing complete, and the idea that a programming language has to be able to solve any computational problem if you give it enough resources, and the Turing test, of course, the AI thing. If you can convince a human they're having a conversation with another human rather than a computer. I don't think anything's past that yet. That was pretty much all I had. Questions? Disagreements? Discussions? Languages I should have covered?
Where does Lisp appear in the timeline?
Lisp appear? When does Lisp appear?
I think
it's made of brackets, isn't it?
Early 60s.
Yeah.
But I don't know what precedes it.
I think it's not on there. Lisp.
It precedes Smalltalk, it postdates Simula, so somewhere in between those two.
Yeah. Early 60s. I saw some Lisp once. It's brackets, isn't it? It's just brackets. Endless brackets.
Yeah.
And what else isn't on there? There's something else that I kind of missed as well. Haskell.
Yeah, Haskell.
Like the Ruby.
There's those Lambda expression languages.
Yeah.
Do you want to talk about that for a minute?
I don't know anything about it, to be honest.
No.
I'd love to. But
That's quite trendy at the moment, isn't it?
what, functional?
Yeah.
Yeah.
You know how the link has a... You can go that way instead of writing select line.
Yeah, you can pass functions as variables, which, so functional languages do seem to be the flavour of the month. I've seen Ivan Towson give a few talks in F#. I even wrote some F#. but I don't think I'm really getting it. I've kind of written F sharp here. I'm kind of trying to force it to behave in a classical way, which is kind of not the point. Apparently there's a book called F sharp for C sharp programmers, which starts you off writing this kind of thing and then leads you into a more functional style. So I should probably do that. F sharp
And
is...
JavaScript apparently is very functional. That's why people cock it up so much when they start out.
Yeah, and I spent 15 years cocking up JavaScript. Like, it's got curly brackets, and I see curly brackets and go, oh, it's just like C sharp. Oh, shit, it's not. But yeah, functions are first-class citizens in JavaScript, so you create a variable that's functional, you can pass it around and call it, execute it, do all the function things to it.
You can do the same with C sharp, of course.
Yeah. Yeah, and in C sharp, I think now, like, we've been lambdaing for so long that it just kind of feels natural. It's just part of, it's part of your fluent C sharp writing. It doesn't feel like you're writing in a functional style. It just feels like you're writing C sharp. But you are.
Java 8 have gone all that way apparently.
Yeah. So it's interesting as well that C sharp has gone from being a Java killer to being in the lead, and Java is now kind of playing catch up on C sharp.
So what about all these any new kids on the block and general development of the ecosystem and languages? Is it so that there are few established ones which can consolidating with the ever go away, or will there be a completely new one that will supersede the XML completely, or this kind of speculation will be very interesting to hear. What's your feeling about the ecosystem of languages now? Are there too many of them, or too few?
They do seem to.
Have they built
There's always big popular ones. I mean, no one's really writing in modular 2 anymore. So we're all writing in C sharp. Some of us are writing in VB. But they're the dominant languages on Java, I guess, on Windows.
See, Google's pushing Go as a language.
Yeah, there's a new movement, like the Gopher movement, with a strange logo.
And Apple just announced a new language called Swift.
Yeah, which is like Objective-C, but it's got lots of sort of functional words in it. It's got lots of lets in it.
There's lots and lots of new languages coming out all the time. The key thing is the killer app. When was Ruby? Sorry, not Ruby. Ruby on Rails.
Rails was.
2006, because Ruby itself was 95, and a language
No,
that was
93.
a niche, 93, all right, as a niche language for years and years and years, and then somebody they did Rails and posted the YouTube video of them doing stuff, and then people said, that's freaking cool, and suddenly it took off.
Mm.
And so there's lots of niche languages that are out there that are probably in a very similar situation to what Ruby was.
Yeah, but was that an inevitable course because of needed functionality, or just a fashion that a package in a cool way? That's the important question.
I think it was that Ruby didn't really do very much that nothing else did until Rails.
Was that the only way of doing it, the Ruby Rails? Would it mean other solutions to add
Why
to
do people
Java
build
or-
different houses? Why do people run different cars? Different people value different things in their languages. I come from a strict typing history. I like strongly typed languages. I'm learning Ruby at the moment, and I feel like I'm working without a safety net. It's freaky, but I'm enjoying the experience. Other people come from a dynamic languages background and find things like C# really, really restrictive and constraining, and the language gets in their way. So it's just a fashion thing. I don't think we'll ever converge in one language, merely because of human variation, let alone anything else.
So you don't think that there will be a time where there will be a translator or port to link all languages together, or make all languages kind of translatable?
It's only a framework.
Yeah. Yes, well done. A lot of the stuff we looked at today, I recently had to translate a Ruby curriculum for this bootcamp from Ruby to C#. You could just about write a parser to do that, but you'd have to do a bit of type inference, but it was one of those jobs that you could have automated in a month, or you could have just done it in 2 weeks. So there's no reason why you couldn't translate between many of these. I mean, actually, with Ruby, you could chuck Ruby into, you could treat Ruby as Iron Ruby, compile it down to IL, and then decompile it back up to C#, I guess. So there
It might
is
be fun to do that just to see.
if it's possible. There is a whole lot of commonality between. We're all going to be programming in JavaScript in a couple of years. I think. What are people's thoughts on this? Like, I think what happened was jQuery suddenly made it possible to write JavaScript to target everything. So JavaScript got really fashionable, and all the browsers went, "Oh, okay, we better support it properly," and now we don't need jQuery anymore. And now there's like millions of JavaScript developers, and so we need Node so that we can. All of our JavaScript developers who can develop in JavaScript in the browser can also develop server-side. So I think, JavaScript that's going to be a thing. Like half of all jobs are going to be JavaScript by about 2015.
Except now we've got TypeScript because JavaScript sucks.
Oh, yeah.
JavaScript. Trying to patch that up.
So TypeScript is like JavaScript made to look like C#, isn't it? JavaScript with classes and then...
Well, yeah, it is. It's JavaScript, but with compile time type checking. And then all the types go away. It's just JavaScript's the output. But it's basically all the types of JavaScript sort of polished off. So you can say, yes, when you call this function, I want the compiler to make sure that you are actually passing me an integer and not a string or an object or whatever you want to pass me.
Yeah, craziness.
Yeah.
And they're not CoffeeScript is. Who keeps saying coffee? And
It's another compiled JavaScript language.
Same thing. The same thing. It generates JavaScript at the end. So it's just
It's got a lot of functional things, Lispy things, maps and selects and
projections and reductions and
yeah,
sort of nonsense.
but it goes the opposite way. It's totally untyped. It's a bit like Lisp and Ruby. There's no type.
This is why I keep going coffee, because I'm hanging out with Rubyists.
Yeah.
They're all right.
Ruby
Don't get
guys
me wrong.
love it. Yeah.
Here's the default. The Ruby project's default for JavaScript now is CoffeeScript.
Yeah.
That's really common. So don't add CSS or JavaScript.
Whereas you, my strongly typed brothers and sisters, prefer TypeScript. Interesting. But yeah, I think JavaScript is increasingly the lingua franca, the Latin of the web.
So what is Rails?
MVC framework for Ruby. So as Rails is to Ruby, so ASP.NET MVC is to C#.
Any comment on the debugging or probability of correctness of these languages? When you look at that,
Debuggability.
prove that, how easy is it to prove that your code is correct using different languages? That's one criteria.
C# I can prove my code is correct. I can prove my code is correct almost never. But hypothetically, I can prove that my code is correct really well. I've got a compiler to lean on. I've got an excellent set of mocking frameworks, testing frameworks that I can use. JavaScript's getting there. We've got QUnit, Jasmine, that kind of thing. So we can test our JavaScript. Things like TypeScript apparently give us type safety at compile time. So JavaScript's pretty good. Even dynamic things like Ruby, harder. You end up writing a lot of tests to do the job of the compiler. I see the Ruby students writing tests which say things like, I expect that method to return an instance of this type. Which you think, God bless you.
It's good coverage though.
Yeah. Oh, huge coverage.
I read some interesting statistics about programming languages and that, which just messes with the brain. If you look at the average productivity of a developer, it comes out around about 5,600 lines of delivered production code per year, regardless of the language.
That's interesting.
Programming in SSLT.
But if it's XML, it goes
Copy-paste.
The velocity of it seems that even if the language is really, really expressive, you still get the same number of lines, but it does more because it's an expressive language. The other interesting thing is that the number of defects per 1,000 lines of code is on average, the same regardless of the language. So it seems like productivity and vocal reports are much more to do with the stuff between our ears than the language we're using to express it. And these are stats over very big projects, very small projects, over a long span of time.
That's really interesting.
Do you think C# will comes to a natural end in such operation?
As in, will the language stagnate? Will the language stop being developed, or will they? I hope not. I really like C#. Yeah, my genesis was a VB3 programmer originally, and now when I write VB, I feel dirty. Yes. So